All right, guys, so today we are going to be talking about graphing cosecant and secant graphs. Honestly, if you can graph cosine and sine, these are a piece of cake. So let's go ahead and take a look at what we've got here. So basically, what you're going to be doing when you take cosecant and secant, what you're going to do is you're going to take your reciprocal. So cosecant is the reciprocal of sine, and you would go ahead, graph your sine function, and then you would more or less reciprocate it as it says. So kind of let me show you what I mean by that. So if we were to go ahead and graph this, let's consider this is cosecant. So I'm going to treat this as if it is its reciprocal, and I'm going to graph sine x. So if we go ahead and graph that, I'm going to go ahead and recall that I've got my original parent function, which would go pi over 2, pi, 3 pi over 2, and 2 pi. And if I'm going to do sine, remember sine starts at the midline, and it's going to go up to a maximum of 1 and go down to a minimum of -1. And so at pi over 2, we're equal to 1 pi. We're back down here at the midline, 3 pi over 2, -1, and 2 pi. We're here. So we more or less have a graph that looks like this, okay? And that would be sine. Except here, we're not graphing sine. We're going to be graphing cosecant. So really, what we're going to want to do is we're going to want to do this as what we're going to call a ghost graph. And so we're going to go ahead and draw like that little graph that we would normally have for sine, but we're going to do it as dashed lines. And then what I'm going to do is I'm going to go ahead and from there, every single place where my function now intersects my x-axis, or actually I should say my midline, wherever it intersects the midline, is going to become a vertical asymptote. So I'm going to have a vertical asymptote at 0, pi, and 2 pi. And then everywhere that I have my graph, I'm going to go ahead and reciprocate it. And that's what I've got here. So I'm just going to flip it. So what was going up is now going down. What was going down is now going up. So right here, it's going down, it's opening down, it's concave down. Now we flipped it, it's concave up. Here, this is concave up, and we flipped it, and now it's concave down. So what you're seeing in blue is the graph for cosecant. I would have my vertical asymptotes right here at 0, pi, and 2 pi, and I'd have my graph right here. And it would follow along those asymptotes while never touching the asymptote, because that is an asymptote. And going ahead and going in opposite directions. It would also continue to be periodic. So right here, if I went from 2 pi to 3 pi, for example, I would have another parabola going up. And then from 3 pi to 4 pi, I'd have another parabola going down. Likewise, from 0 to -pi, I'd have a parabola going down, and then a parabola up, so on and so forth. Okay? Okay, so what does that mean about the domain of the function that I would have for cosecant? Well, I have every single value. If I think about what I have for sine, sine is defined -infinity to infinity. However, cosecant is not, because every single place where sine is equal to 0, so if I take sine x is equal to 0 and I turn that into its reciprocal, so meaning I put it over 1 and flip, then I would have cosecant x is equal to 1 over 0, right? And I cannot have 0 in my denominator. That is undefined. So that is why cosecant has a vertical asymptote at 0, pi, and 2 pi, because at 0, pi, and 2 pi, sine is equal to 0. So my domain, the way that I'm going to go ahead and write this is that I'm going to go ahead and say the domain is going to be all real numbers except going to be multiples of my value of pi. So basically what I'm going to say is I'm going to say it's -infinity to infinity except x cannot equal pi k. And then I'm going to say where k is an integer. Because if I do 0 pi, well, that's 0. If I do 1 pi, well, that gets me pi right here. 2 pi, that gets me what I have right here. So that's what I'm going to do with that. My period, it's going to start to repeat every 2 pi. My range. Now, range of sine was from -1 to 1. But if you notice right here, this graph is going to be this blue area. So again, it's going to be above 1 here, and it's going to be below -1 here. So it's going to be the opposite. So it's going to actually be from -infinity to -1, including -1, union from 1 to infinity. Because again, I'm not going to have any values between -1 and 1. So everywhere that you see this sine graph right here actually is not part of my function. It all goes down to -infinity. And then my asymptotes, the way that I'd go ahead and write that would be x equals, because x equals is going to be that vertical line. And then it's going to be pi k. So whatever your asymptotes are, whatever you write for your asymptotes is going to be whatever you're excluding from your domain. So whatever you have here should be the same thing as what you have over here. And then again, where k is an integer. And again, it needs to be an integer for k because that's how we're going to get those equally spaced intervals that we're going to need. Because if I didn't say that, then I could say, well, it could be I could say k is 0.2. Well, is 0.2 pi going to be an asymptote? No, it's not. It's only at 0, 1, 2, 3, 4, 5, 6, so on and so forth pi, where we have an asymptote in this particular one. Now, obviously, that changes if we have shifts and stuff like that. All right, let's go ahead and take a look at what we have for secant. So secant is the reciprocal of cosine. So again, I'm going to treat this as if I had cosine of x. So let's go ahead and label my axis and graph that. Here's the graph of what cosine would be. We would start at our maximum, go to the minimum at pi, and cross back up to our maximum again at 2 pi. So just like what we did with cosecant, where we went ahead and flipped our graph everywhere where we crossed our x-axis, we're going to have a vertical asymptote. And I shouldn't say that. I shouldn't say that we cross the x-axis. I'm going to go ahead and say whenever we cross the midline, because if we shift up or down, it's not the x-axis, it's the midline. Okay, and then I'm going to have a graph that goes kind of like this here. So everywhere that your original graph of cosine is going to open down, you're going to invert that and open up for secant. And everywhere that it would open up right here, we're going to invert it and open down. So in this particular case, you're going to have 2 halves going up and 1 whole going down. But that's because what you can't see is you can see like this continuing version of the graph right here that you would have. So again, both graphs are just going to be just a constant flip-flopping of parabolas just going on and on and on and on forever and ever. So that's essentially what you've got. Okay. All right. So now what is our domain of secant? So it's going to be exactly the same thing as cosine. Well, I shouldn't say exactly, but what you're going to have is you're going to have from -infinity to infinity, except x cannot equal pi over 2 plus pi k. And that's because right here I have pi over 2 where it cannot equal it. And then if I add another pi, right here it's pi over 2, it cannot equal that because that's going to be our midline. Then here at 3 pi over 2, a whole entire pi later, it also would be an asymptote. And so if I plug in 0 right here for k, that's just going to get me pi over 2. If I plug in 1, that's 1/2 plus another whole, that's going to get me 3/2. So that's why we're going to use this. And then again, same thing where k is an integer. You must include that statement. Range. Range is going to be identical to secant. So that's going to be from negative infinity to negative 1, including negative 1, union 1 to infinity. Period. Same thing. It's 2 pi. And then my asymptotes, again, it's going to be the same thing as what's being excluded from my domain. So that's going to be x equals pi over 2 plus pi k, where k is an integer. Okay, so let's go ahead and take a look at the next problem that we have. Actually, I'm limited to 15-minute videos, so I'm going to go ahead and do this in the next video.